My name's Andy Pershing. I'm the Chief Scientific Officer here at the Gulf of Maine Research Institute, and I also run our Ecosystem Modeling Lab.
Awesome.
Being a scientist, everything is about data, and it's more about what kind of data you're playing with or how you're collecting it. So for my work, I'm really interested in how conditions in the Gulf of Maine have changed over time. And so I'm using data on temperature conditions in the Gulf of Maine going back to the 80s or sometimes even to the early 1900s. And we're using data on the abundance of different fish or plankton species and trying to look for patterns. The language that we use in science is very much grounded in probability. So we're always talking about things being likely or unlikely, things being relative amounts of certainty. So the only thing we can do in science is we can prove something wrong. We can never prove something right? You can never prove with to 100% certainty that something is true. But you occasionally can get the data or do an experiment that will tell you that some idea is absolutely wrong. So, variability is a really tough concept for people to deal with. And where it comes up most for me is I find myself talking about climate change a lot. And, in climate change, we're talking about really a subtle shift in the probability. So today it happens to be snowing here, at the first day of spring, So the question is, how likely is that? And is it more likely or less likely now than it used to be? And so it's really thinking about the fact that this concept that if you went out and made the same observations that you wouldn't always see the same thing is a really challenging part because we're so used to just our one experience. And a lot of times the variability is what you're trying to explain. Why it's warm today and cold tomorrow, trying to understand those changes. But it's also important to understand the different components of variability. And the one we really worry about is this random variability, the fact that if you went out and took the same measurements or measured the same thing in a bunch of different habitats, that you wouldn't always get the same outcome. And it's that variability and the bell curve and all of that stuff that we worry about. And so characterizing that variability is essential. But ultimately, it's really driven by your question. You have to really connect the question that you're asking with the samples that you're taking, with the experiment that you're doing to make sure that it's actually going to, answer that question. So the more samples you take, as you begin to average them together, you can become more certain about the average and about the variance around that observation. But that only works if your samples are really independent realizations. And so the way this would come about, like in a field program, is that if you throw a quadrat down and you count up the snails in the quadrat in one section, and then you just sort of slide the quadrat over, you're really sampling very similar places. It isn't random. And so I think the ability to work with data, to manipulate it and to understand it and to ask questions about it is just so essential to both to the practice of science, but it's also really part of modern life. I mean, it's what Amazon is doing when they're trying to figure out what product to sell you next. They're looking at the data and trying to pull that answer out. It's what your bank is running to figure out what the interest rate should be, or what your insurance company is doing to figure out what they should charge you for your car. So, understanding data, it's just part of modern life, and the people that understand how to work with data are going to be at an advantage.